Okay, so same exact problem. Only now A still has a mass of 5 kilograms, right? And then B has a mass of 1.78 kilograms, right? Now, we could still guess. I think maybe this is a case where it was a 25-degree angle here, right? This might be a case where it actually, this is 25. It might be a case where actually A accelerates down the plane, but let's still guess that the direction of acceleration is this way, right? That everything accelerates that way, right? Okay. Our force of A, this parallel force acting down the plane, is mg sine theta, right? Okay, so let's bust that guy out here. 5 times 9.81, 9.81 times sine of 25. Sine of 25 is 20.729 newtons, right? Okay. The force down on this guy we can figure out is mg, right? So it's 1.78 times 9.81. Of course, this will be less than this, and we'll be wrong about our direction of acceleration, but let's just let it happen. Okay. So let's see. Store that guy in A. I've stored this in A in my calculator. So all I have to do is type an A, and that'll come out, right? And then I'm going to go 1.78 times 9.81. I'm going to store that in B. This is 17.4618. Okay. And that is our downward force. That's this guy here. And I'm storing that in B on my calculator, right? So if we look at the situation for A, we set up F equals ma, right? That's all we're doing now. Right? We'll end up with, well, the tension is up the plane, right? And here the tension is up on this guy, right? So tension minus 20.729. That's supposed to be a decimal point. Okay. There. Okay. Equals 5 times A, right? For B, our formula looks like the protagonist, this guy, 17.4618 minus T equals 1.78 A, right? And then we'll just do what we always do, right? We're going to add these guys together. And lo and behold, we're actually going to get a negative number on this side. Okay, so we have alpha B is this thing, 17.4618, right? Minus 20.729, right? That's going to equal 6.78A, right? So we just add these guys together, right? Okay, so that guy minus, and I've got negative 3.267 equals 6.78A, right? So now I'm just going to divide by 6.78. I get negative 0.481, negative 0.48195 meters per second squared. So it accelerates down, this thing accelerates down negatively, right? So actually it's accelerating up. The direction of acceleration is that way and this way. And that's because although this is on an inclined plane, it's a frictionless plane, and it's got so much more mass that even when you multiply by the sine of 25, that number is bigger than this number. Should have seen that coming, right? But anyway, it's not a big deal, right? So the acceleration is tension in the cable, right? So notice that we got negative 0.48, right? What does that actually mean as an answer, right? Okay, so let's see. It should say acceleration of B downward, right? It doesn't accelerate downward, it accelerates upward, right? Now we'll still find our tension the same way, right? So we're going to go take this formula here, right, and go tension equals 5A plus 20.729, right? So the tension is 5A, so 5 times negative 0.48195. You got to put the negative in there. You got to keep it in there, right? Once you get the negative, there it is, right? And then plus 20.729. Okay, so that guy times 5 plus this thing. I get 18.3196. Okay, as my tension. Okay, so notice how accelerations will come out negative. The tension is never going to come out negative, because what would that mean? Anyway, good enough.